All right. So question number 1. So rewrite, it's asking us to rewrite this number in decimal notation without the use of exponents or scientific notation. So it wants me to do this number without the use of exponents or scientific notation. So how do I get rid of this part, in other words? That's what they're really saying. So they have the number here, 2.912 times 10 to the 9th. So what is that? Like I said, I don't need to rewrite it. What does that 10 to the 9th power do? Do you remember? Let's think. I don't want to just give you a rule. I want to think with you. What if I said, hey, I'm going to go buy some kind of special. I'm going to go buy some ice cream cones for a bunch of my my girls' soccer team. So let's say I'm going to buy 10 ice cream cones for the girls' soccer team, and they're $2.92 each. So how much is that going to cost? How do we let's just think about what happens when you multiply a number by 10. If it's $2.92 for each ice cream cone, and I buy 10 of them, how much is it going to cost?
$29.20.
Yeah, it just moves the decimal one spot, doesn't it? Exactly, right? We know that, don't we? It just simply moves the decimal one spot. The bill would be $29.20, right? So multiplying by 10 moves it one spot. What if instead I decide to buy ice cream cones for my daughter's whole soccer league? That would be kind of crazy. I don't think I'm going to do that. So 100 girls in the soccer league. I'm going to buy ice cream cones, $2.92 for 100 girls. What do we do then? How much is that going to cost me?
So you would move the decimal twice to the right.
Right. Once, twice. Yeah. So that'd be $292, wouldn't it? So that's stuff you already know, right? I'm not showing you stuff that's new. You know that. You know when you multiply by 10, it just moves the decimal one spot. And when you multiply by 100, it moves it two spots. That's what's nice about 10. If I was to take $2.92 and instead of multiplying by 10, I was to multiply by like 8, say there were only 8 girls who wanted ice cream, that's going to be a new number completely. In other words, you cannot just move the decimal, right? You know that, right? I don't know what it would be. It would be whatever, 20 something. But you can't just move the decimal. But if you multiply by 10 or 100, in those cases, you can just move the decimal, can't you? Why is that the case? If a child was to ask you, why, Mr. or Mrs. Your Name, when we multiply by 10 or 100, why can we just move the decimal? But when we multiply by other numbers like 8 or 7 or 6 or 9 or whatever, we can't just move the decimal.
Because we have a base 10 system. So whenever you multiply by numbers that are multiples of 10, that's when you're able to move the decimal.
Martine, that makes me so happy. That just makes my day. I know I'm a strange math teacher that gets excited about weird math things, but to me, that is great. It's like music to my ears. Exactly. I hope that's how we all understand. That's what we've studied, huh? That's what we did in the first part of the course, is that we have a base 10 system. Therefore, if you multiply by things like 10 or 100, 10 kind of numbers, it just moves the decimal. It just changes the places. Exactly. Beautifully stated. Exactly. Well, that's what we're doing here. And if you think about it, there's a nice pattern, isn't there? Like this is really 10 to the first power, excuse me. And the decimal, notice, moved one place. And 100, that's 10 to the second power. That's how you could rewrite 100, right? 100 is 10 times 10. So if you think about it here, let me write down here where you can see it. Well, here, I'll put it there. 10 to the second power. And notice what the decimal did. It moved 2 places, didn't it? So in other words, if we will just write the number, the 10 or the 100 or the 1,000 or whatever, as 10 to a power, because 100 is 10 times 10, 10 squared, that will tell us how many places to move the decimal. Notice that the power on the 10 tells us how many places to move the decimal, because we have a base 10 system. Like Martine says, we have a base 10 system. So it's just about moving the places. That's all it is when you multiply by 10 or 100 or 1,000, because those are just a bunch of 10s multiplied. Exactly. So what should we do with this 10 to the 9th power? Here's the decimal right there. How many spots is the decimal going to move?
9 spots.
There it is. So we're going to take 2.912, but the decimal is going to go 1, 2, 3, and then the rest of the movements are going to bring in zeros because they go beyond the edge. 4, oops, I don't know what just happened there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to bring in 6 zeros, isn't it? Because we had to move 9 places to the right. The first 3 jumps, right? There was 3 jumps right here. That got us to the edge of the number. And then when you go beyond the edge, it brings in zeros. So what's the actual final answer? What is this number? It is 2912 and 6 zeros. And there it is. That's what you type in. I don't think they want you to put any commas in there. Just type it in just like that. 2912 with 6 zeros. That's the actual number. And so what did we just do? We just changed the format of the number. In other words, 2.912 times 10 to the 9th and this 2912 with 6 zeros, those are the same number. They're just being said in different languages, like me saying one or uno. I'm saying the same number in 2 different languages. Well, that's what we're doing. This 2912 with 6 zeros is the same as 2.912 times 10 to the 9th. It's just 2 different ways of saying the same thing. One of them is called scientific notation. It's how scientists say really big numbers or really small numbers. And the other one is called decimal. This is just decimal notation or regular notation. So that's what this section is all about, changing between the 2 languages, between decimal or regular notation and scientific notation, where you have times 10 to some power like that. That's what it's all about. So there we go. There's the answer to that question.